Hill for the introduction. So today, I'm glad to hear that I've achieved the status of being a well-known PostgreSQL developer. Hopefully you weren't all sitting there thinking, who? But I'm really pleased to be here. This is my second trip to India, my first visit to Bangalore. I'm having a great time being here in your country. It seems like a pretty great country, and I'm hoping to be back. But today I'm going to talk about PostgreSQL past, present, and future. Sorry? Oh, okay. I shouldn't fall off the stage, I'm told. Okay, so I'm going to start with a very brief history of PostgreSQL, talk about how we've gotten to where we are today. Then I'm going to talk about some of the new features that are here today already in PostgreSQL 9.5, which are pretty exciting. But as a developer, I'm always ahead of where the release cycle is. So I'm very, very focused on finishing up 9.6 at this point. And some of you may know that there's a new feature in 9.6 that I worked pretty hard on. So I'm going to talk a little bit about that and some other things that are coming in 9.6, and then a little bit about what I think the future holds. So if you've heard a PostgreSQL history talk at any point in the past, you probably have heard someone say that Postgres began as a research project at the University of California at Berkeley in 1986. And it remained a university project for a decade. So we are 30 years into the development of this technology. 30 years, right? The history of the open source project goes back 20 years, but the overall source code that we're working with has a 30-year history. The initial versions didn't support SQL. They had their own query language called Quell. SQL support wasn't added until 1994. But in 1996, the project was renamed to PostgreSQL, and that's really when the modern era of PostgreSQL as an open source project began. I started using PostgreSQL in around 2001. I've actually lost track of exactly what date that was. But looking at the list of limitations that we had in 2001, you might ask, why in the world did you start using PostgreSQL in 2001? I mean, we had no built-in replication. We had no replication at all. Sloaney did not exist. You could not replicate in PostgreSQL unless you wrote it yourself, which I'm sure a few people in this room probably did. There was no PG pool, right? This sort of fundamental piece of clustering software that many of you are probably familiar with did not exist. We did not support Windows. We did not support schemas, right? All of your SQL objects were in a single flat namespace. There was no auto vacuum. I ran my first PostgreSQL database for 4 or 6 months or so, and then I said, man, this thing seems like it's slower than it used to be. Yeah, it turns out, for those of you who may not know, the time between vacuums should be a little bit less than every 4 to 6 months. So I learned something from that experience. One of the limitations that put me off on using PostgreSQL at this time and that caused me to use MySQL for a while longer than I might have otherwise is you could not drop a column from a table, which I thought was just an insane limitation for a database system to have. And certainly by any modern standard, this version of the database was incredibly slow. So fortunately, there were a lot of people like me who saw a lot of value in the product already at that time, despite the fact that it had all of these limitations, and they put a lot of work into overcoming those limitations. Just the following year in PostgreSQL 7.3, we got schemas and the all-important drop column command. It took another 10 years to get the bugs out, but we got there. In 2004, we had the first release of Sloaney, so now you had an off-the-shelf replication solution for PostgreSQL, which many people still use today. 2005, we got Windows support in Postgres 8. 2006, we had the first release of PG Pool 2. very important Postgres add-on project. And there was a ton of performance work that was happening through these years as well. There were a series of releases for like 5 years running where we doubled the write performance of the system in every release. That's a big, big multiple by the time you get through 4 or 5 releases of that sort of thing. I think one of the really big turning points was PostgreSQL 8.3, which added heap-only tuples to the system. Pavan did that work back when he was at Enterprise DB. And single-byte Varlena headers, so everything just got smaller and faster at this point in time. It was a huge step forward for the database. It completely changed the performance characteristics of the system. And that was also a release that turned auto vacuum on by default and made significant improvements to it. So this was the first release where you could conceivably turn on the database server, not think about vacuum, and have things be okay, right? So big, big step forward. And then fast forwarding a little bit more, in 2010, PostgreSQL 9.0 was released, and that added 2 or 3 really big features. Streaming replication was one, so now you could do high availability. Hot standby was another, so now you could build, at least for certain applications, cluster read scaling clusters using replicas of the main server for read load balancing and reporting purposes. And it also added PG upgrade, which meant that you could take very large databases and upgrade them to a newer major release without very long downtimes. You had to be a little bit brave, but you could do it. So this brings us up to about 5 years ago, right? February 26, 2011, PostgreSQL 9.0 is the current release. Most of the really serious performance problems had been fixed by this time. Improvements to vacuum and the auto vacuum daemon had made the system a lot easier to maintain than it had been in previous releases. The free space map management in 8.4 had been a big part of that also. Sloaney and PG Pool were both mature projects at this point, and there were a lot of other tools that were on the scene at this point also. And you could now actually use PostgreSQL in environments that required high availability. That's a pretty big deal. High availability is the thing that a lot of people want before they do anything very serious with the database. So we were beyond hobbyist projects at this point. You could really start to do some cool things with the system. And progress continued. In PostgreSQL 9.2 and in 9.4, we really made significant improvements to PostgreSQL's ability to scale on large systems. The performance when you just run one query at a time was about the same in 9.0 as it is today. But when you ran many queries at the same time, 9.0 didn't look so good. We've made big improvements there. Foreign data wrappers came in with 9.1. They became writable in 9.3. Postgres FDW started shipping in the core of the system. We added JSON and later JSON-B. JSON-B is for those who may not know, is a data type that stores JSON data, but in a binary format that is optimized so that you can perform structural operations on that JSON data inside of the database. And that release also added advanced indexing for JSON data, which meant that you could do efficient searches for JSON documents in your database that matched certain properties, which is really important because somebody in this room can probably think of another system that sports the ability to do lookup of JSON documents with certain properties inside of a database, right? And now we could do that too. So that was very important, and in fact, in some ways, ours is better. In PostgreSQL 9.3, we got the optional ability to checksum every data block in the database, which provides a very powerful protection against data corruption. If you are concerned that your hardware might be unreliable, and that's probably a reasonable thing to be concerned about, checksums will protect you against that. And this is just a smattering of the features that have been added in the last 5 years. I mean, this slide is sort of intended to cover PostgreSQL 9.1 through PostgreSQL 9.4, but in fact there was an awful lot of other stuff that happened here, and I arbitrarily picked out some of my favorites. But there's been a tremendous amount of progress over those years. And that kind of brings us to where we are today, which is PostgreSQL 9.5. And so I'd like to go through the PostgreSQL 9.5 major features list as it appears in the release notes. But I've added one thing to the list, which I think is really important and which somehow did not make it onto the major features list, which is I think we've continued to make some really important scalability improvements in PostgreSQL 9.5. And so I'd also like to talk about those. So first of all, we have insert on conflict. This feature is due to an incredible amount of hard work by Peter Gagan. So what the on conflict clause allows you to do is to say what you would like to have happen when there would be a duplicate key violation as a result of the insert statement that you just tried to do. So the default behavior, you will hopefully be pleased to hear, is throw an error. I realize there are other things that you could do, but I'm pleased to say that that's our default. But now in 9.5, we've got a couple of other options. And one of those is do nothing. So try to insert the row, but if there's already a row there with the same key values, then just don't insert the row after all. What's even more exciting is the do update set clause, which guarantees that you will either succeed in inserting the new row or you will succeed in updating the existing row. What you will not do, and this is very important, is fail with a serialization error. A huge, huge amount of work went into making that happen. So this is a very desirable feature for application developers. You might imagine you have some cache of data that you want to synchronize back to the database. You don't have to keep track of which rows are already in the database and insert the ones that are not present, update the ones that are present. You can use this statement to just push it all in, doing inserts and updates as needed. This is a very popular feature. Other people have it also. It's often spelled merge. We picked a different syntax because our feature is less general. But it's less general for a really good reason, which is the thing that I said a minute ago. It works under concurrency. It doesn't error out. That's a big deal. How many people like writing applications where sometimes the database gives you errors for reasons that you can't understand? Anybody here like that? Yeah. Oh, wait, we got Amol. Amol likes that. All right. Amol's the only one who likes that. So I think it's good that we don't have that behavior here. And that was a lot of work. So another new feature that we have in PostgreSQL 9.5 is grouping sets. And I've got an example here on the slide. On the first line, you see a query where we're adding up column C for every distinct value of column A. Then on the second line, you can add up all of the values in column C for every distinct value of column B. And now in PostgreSQL 9.5, you can do both of those calculations with a single query. Now I know what you're thinking. You're thinking, but wait, I could have written union all, and I could have gotten the same behavior that you're now telling me we can do with PostgreSQL 9.5. And that's true. You could, but this is faster. This is faster. We can, in most cases, compute both result sets with a single pass over the data. Whereas if you write this as a union all query, you will make two passes over the data. And two is more than one. PostgreSQL 9.5 now offers row-level security. We could sort of do things like this in earlier releases, especially in 9.4 where we had security barrier views. But in 9.5, this got a lot more transparent. You could just say, I'd like row-level security, please. And the database says, OK. And so the basic idea here is that unlike table-level security or column-level security, row-level security doesn't give you errors. If you try to access a table to which you do not have rights, you get an error. If you try to access a column to which you have rights, because you can grant access to individual columns, you get an error if you don't have access to a column and you mention that column name in your query. But row-level security works differently, and for a very good reason, which is that if you type select star from table and it comes back and says, error, you don't have permission to see all the rows, it's very hard to get access to the part of the data in the table that you do have access to. So it doesn't work that way. We just hide the rows that you don't have access to. This turned out to be a pretty hard problem. The technology underpinnings of row-level security have been in development for 2 or 3 releases, and we've sort of incrementally been getting closer to this thing. Because one of the really important things about a security feature is that there can't be a way to bypass it, right? And the simple approaches that you might think of to implementing this feature work fine unless you've got somebody who really knows the system well and can trick the optimizer into doing something that it shouldn't, and through some side channel attack you can get your data out. So a lot of work went into making sure that this feature would actually provide the security that it says on the tin that it should provide. And I've got a syntax example here showing you how easy this is to use. You just create a policy on a table, you say which rows you want people to be able to see, and then you enable row-level security, and you're done. You can still see all the rows. Anyone who has the system-wide permission to bypass row-level security can see all the rows. Other people can only see the rows that you let them see. And you can do these policies so that you grant access to particular rows to particular users. You can see these rows, you can see those rows, you can see both sets of rows, and you can use groups as well. PostgreSQL 9.5 also brings in BRIN indexing. BRIN, this work was done by Alvaro Herrera. It stands for Block Range Index. And it's a really cool piece of technology. The idea is that you want to create a small index on a big table. So a B-tree index is perfectly accurate. It knows about every value in every row of that table. But that can get big. If you've got a 100 megabyte table, creating a B-tree index is probably a fine thing to do. If you've got a 100 gigabyte table, your B-tree index may be very big. You may not be able to fit the table and a couple of B-tree indexes on that table into the memory of the computer that you have. Now, you could buy a bigger computer, but you could also upgrade to PostgreSQL 9.5 and then use BRIN to create a smaller index, which is cheaper. So the simple way to think about what this technology does is that it goes through each page of the table and looks at the indexed column and stores the largest and smallest values that appear on that page for that column. And so then when a query comes along looking for a particular value in that column, it can say, well, there's lots of pages of this table that can't possibly contain any data that matches the query that you just submitted. That's pretty cool. It can actually do ranges of pages rather than individual pages to compress the size of the index down even more, admittedly at the cost of making it less accurate. And it can actually sometimes store things that aren't quite exactly the minimum and maximum, but trying to explain exactly what you can store other than minimums and maximums would cause me to spend like 3 speaking slots trying to talk just about that. So I won't do that. It's actually not that interesting. It's basically minimum and maximum, but you can do some other things too. Another really significant change that happened in PostgreSQL 9.5 is that sorting got faster, at least for certain data types. The big one is varchar and text. Numeric was also improved. Peter Gagan did the basic work here for varchar and text. Andrew Geerth did the numeric work. And sorting text columns is now really a lot faster in most cases. It does depend somewhat on the distribution of your data. If you have a large number of strings and the beginnings of all those strings are identical and way out at the end they're all different, then you might not see a speed up. But most people are going to see sorting text much quicker in PostgreSQL 9.5. And basically the way this works is we store the first 8 bytes of every string in a very compact area of memory, and we can usually decide which things should come first by just looking at the first 8 bytes. And then if we can't, because they're equal, then we have to go look at the whole string and compare that, and that takes more time. But usually we don't need to do that. So overall, text sorting and numeric sorting get much faster in PostgreSQL 9.5. And then the one thing that I wanted to add to what was listed in the major release notes, and I freely admit to a little personal bias in deciding that this was an important thing, is that we've made some really significant concurrency improvements. Many of you who may have been following my work for a while know that this is an area that I and also my employer care quite a bit about. We want to be able to run PostgreSQL on big systems and be able to fully utilize the hardware on those systems. And we've got some really quite nice improvements in that area that are present in 9.5. If you have a workload which is bigger than shared buffers, you might have shared buffers set to 8 gigabytes, but the active portion of your database, the portion of your database that you're actually querying and using and updating, might be bigger than that. It might be 50 gigabytes. Well, so what's going to happen is you're going to pull pages into shared buffers from the operating system cache, then you're going to evict them, and then you're going to pull them in again. And every time you pull a new one in, you got to kick one out, right? And that process was not any faster is not any faster at 9.5 than it was in previous releases, but it does scale much better. So if you have a workload where you have lots of queries running at the same time, and the working set is bigger than shared buffers, so you're doing a lot of page eviction, you're going to see some pretty significant speed up on 9.5, which is cool and I think important. Also, Andres Friend rewrote our LW lock implementation. LW locks are an internal data structure that we use to protect shared memory data structures. And the implementation that we had works fine on systems with 1 physical CPU or with 2 physical CPUs, but on systems with 4 or more CPUs, it doesn't work so good. So we have a new implementation right now that scales much better to these big systems. And I just want to emphasize that, you know, what does it actually mean when you say a 2-socket system or a 4-socket system? An awful lot of people are running 2-socket systems these days, because 2 sockets may actually mean 32 or more cores, because people have found a way to squeeze a lot of cores into a single socket. And a 32-core system is still a pretty beefy system. There are certainly people out there who need a bigger system than that for their workload, but there's an awful lot of people who don't. So don't be too scared by the fact that we haven't completely licked the problems on 4+ sockets systems yet. But do be happy that we're starting to, because I think, you know, as the years go by, we're probably going to continue squeezing more into each socket, but there will be more and more people who are running these larger 4-socket systems, 8-socket systems, and beyond. And so this work is going to continue. The scalability work, there's a big chunk of it in 9.2, big chunk of it in 9.4, more progress in 9.5, and that work is continuing for 9.6 and beyond. In fact, Amit already has a patch committed to 9.6 that makes further improvements in this area. So with that transition, such as it was, I want to talk a little bit about what's coming in 9.6. And probably many of you will not be too surprised to find that parallel query is at the head of my personal list of things that's coming in 9.6. This is a project that I've been working on with Amit and others for about 3 years now. And it refers to the ability to use multiple CPUs to answer a single query, which is something that we could never do before. So when I said a few moments ago that we have much better scalability right now, we have much better scalability. We can use all of the hardware that you have if you're actually running that many queries. If you've got 64 CPUs and 64 queries, we are now pretty good at using all 64 of those CPUs, 1 per query. If you've got 64 CPUs and you've got 16 queries running at a time, though, things don't look so good. You're going to use 16 of those CPU cores, and the rest are going to sit there not doing anything until you run more queries at a time. So parallel query is the answer to that problem. And just to say a little bit about the development of that feature, because we have not had parallel query for such a very long time, a lot of parts of the code had a deeply embedded assumption that a transaction is something that happens within one process. And all of those things had to be changed. So every layer of the system, from bottom to top, from the lowest level things that we use to do memory management to the highest level thing, which I would view as being the query planner in this case, all of those things needed to be changed. And that took a lot of work. One thing to be aware of is that parallel query plans are different from serial query plans. You don't just get the same query plan and it runs faster. You get a different query plan that is chosen with the idea of parallelism in mind. And because of that in particular, 9.6 will have a lot of limitations in the parallel query department. We will not be able to generate all of the query plans that somebody would like to be able to generate. But we will be able to do some pretty cool stuff. And I'm very interested to hear from people who try to use this feature and see how it works for them. I think that the process of improving this feature is going to take, and getting it to really cover all the cases that people want, is going to take years of work. But 9.6 makes a pretty promising start. We can parallelize not only sequential scans, but some kinds of joins and a few other things, and that's pretty neat. And we'll continue to work on that in the future, I hope. Another thing which is potentially on the horizon for PostgreSQL 9.6 is logical replication. This, like parallel query, is a feature that's been sort of percolating through the community for multiple release cycles. We got the beginning of that in PostgreSQL 9.4 with the logical decoding facility. And logical decoding is a C API. It's a feature that you can use if you know C and don't mind writing C to solve your business problem, okay? But it was a very cool feature and a very fundamental technology, because if you did use it or got some other piece of software that knew how to use it, then you could stream out all of the changes that were being made to the database. Every time an insert or an update or a delete happened, that would pop out as a change stream, and then you could take that change stream and go and do whatever you wanted with it, perhaps apply it to another database. Second Quadrant offers a UDR plugin to do this. Enterprise DB has XDB Replication Server 6.0 is now in beta, which adds this capability on our side as well. But in PostgreSQL 9.6, we might start to get some of these pieces in core, which I think would be a really big step forward, so that you don't need to know C, but you can just do logical replication. And there's two halves of that, one side for the publishing server and the other side for the subscribing server, and those are PG Logical and PG Logical Output. And taken together, that would give us high performance, log-based logical replication in the core distribution, which would be really exciting. And in a couple slides, I'll talk a little bit more about why that's exciting. Another thing that's coming in PostgreSQL 9.6 is some more work on foreign data wrappers. So this was done by some folks from NTT, and my colleague Ashutosh from Enterprise DB did a lot of work to help get this over the finish line. The basic idea is that when you query foreign tables, we want to be smarter about what query we're sending to the remote server. So in PostgreSQL 9.5, if you do a select query on a foreign table and you have an order by clause in your select query, we will not send that order by clause to the foreign server. We will just ask for the data unsorted, and then when we get it back, we will sort it. But it's better to have the other guy sorting, because I always like it when somebody else does work instead of me. It also has the potential to be more efficient, but even if it's not, better you than me, man. Even more significantly, much more significantly, we've also now got join pushdown, which means that if you select from several foreign tables that are on the same server and you join between those tables, in PostgreSQL 9.5, what will happen is you'll fetch all the rows from the first table, fetch all the rows from the second table, fetch all the rows from the third table, and then you'll join them locally. And of course, you won't have any indexes or anything. You'll just have a pile of data that you got from the remote server. And you will have schlepped a tremendous amount of data over the network. This is so dumb that you can't believe it's actually this dumb, but it is. What this feature does is it fixes that. It says, oh, you're joining several foreign tables on the same server. Let's send a join query to the remote server, have it do the join. It has all of the data locally. It doesn't need to transfer it over the network, and it probably has like useful indexes and stuff that it can use to make the join run faster. So we send the join and we pull everything back. There's more work that's still being done here. Some of it may get into 9.6 to add some other optimizations to this as well. And I think that's pretty exciting. I tried to make a list of other things that might get into 9.6. I don't really know how many of these things will get into 9.6. We'll see. We're about probably 2 months or a little more away from feature freeze, so probably be some things landing at the last minute. But these are a few of the things that are going on that I think are pretty interesting. My colleague Thomas Monroe came up with a great idea for a feature called causal reads. And I think this is a pretty exciting piece of technology. Currently, you might imagine building a read scaling cluster with PostgreSQL by having your single write master and then having multiple read replicas. And you send all the write queries to the master and you load balance the read queries among all of the replicas. There's a small problem, which is that there's a narrow window of time during which a query to a read replica might fail to see data that has just very recently been written to the master. And that kind of sucks. And hey, Thomas wrote a patch to fix that problem, which I think is pretty cool. Many of you may know that you can kind of do partitioning in PostgreSQL using table inheritance and check constraints and constraint exclusion and a bunch of these other technologies that have names that are hard to understand. And this is a really, really general feature. In fact, it's too general. It's so general that it's very hard to optimize queries against partition tables so that they actually run fast. And declarative partitioning aims to introduce a new language for defining partitioning into our SQL syntax so that you can have the metadata in the system set up in a way that lets us make queries fast. I think that's a very, very important piece of work. I know there are several people from Second Quadrant working on a column store. I don't think that's been actually submitted to 9.6, but I hope it's something that will come along, if not for 9.6 at this point, probably then for future release. There's some work that's being done on a freeze map, which is a further optimization of our vacuum technology to make that more efficient than it is today. I think that's quite exciting, and there's some work being done on better monitoring facilities also, and I'm sure there's a few people in the audience whose favorite patch I've forgotten to mention, so I do apologize for that. But I think there's quite a bit of exciting stuff that's on the way. So taking all that together, looking at PostgreSQL 9.5, which is here today, and PostgreSQL 9.6, which is in development, where exactly is PostgreSQL today? Well, at this point, we have excellent scalability on two-socket systems, and we're beginning to tackle the issues specific to systems with 4 or more sockets. And as compared with a few years ago, we are now tackling a bunch of really interesting new workloads that we weren't very good at before. High security environments with features like row-level security, unstructured data with JSON and JSONB, and various other things, analytics with Brin, grouping sets, parallel query. PostgreSQL is becoming more and more able to deal with more and more kinds of workloads in an efficient way. And there's a rich ecosystem of tools available. So if you remember all of that slide I put up at the beginning for where we were when I started using PostgreSQL, we've come an amazingly long distance. In fact, even if you look at where we were 5 years ago, which was a much better place, we've made a lot of progress in the last 5 years. We've really taken, the PostgreSQL community, have taken the technology that we've had then and we've built on it, we've expanded it, we've put tools around it, and we've created a database that's ready for mission-critical enterprise applications, the top tier of stuff that you want to do with your database product. That's due to the hard work of a lot of people in this room and a lot of other people around the world. And I think it's a really exciting time to be involved in PostgreSQL. I also think that the future of PostgreSQL is even better than the PostgreSQL we have today. I think logical replication will play a big role in that. It's an incredibly powerful tool. The streaming replication that we've had since 9.0 is great for high availability. It's probably the best tool for high availability that we're ever going to have. modulo perhaps some tooling. But logical replication will allow a whole other set of use cases that are not possible with streaming replication. Streaming replication requires that you've got 2 copies of the database that are byte for byte identical. Every byte is the same. Logical replication lets you move rows around. That's a big difference, because if you can move rows around, then you can do partial replication, where you replicate only part of the database. You can replicate across versions. You can even replicate into some other product that's not PostgreSQL on the other side, or from that product into PostgreSQL. You can even do multi-master replication if you're the sort of person who likes occasionally getting errors that you can't understand. But there's a lot of good things that you can do with logical replication, and I think as that technology develops and expands and works its way into the core product, it's going to be really, really powerful. And I think parallelism is also a pretty transformative technology, which is going to expand our ability to use all of the available hardware in the system. And that's important for a couple of reasons. One is that we've got a bunch of features in recent releases which are leaning in the direction of analytics, right? We are not an analytics database. We are an OLTP database, but there's always fuzzy boundaries around the edges of where does OLTP end and where does something else start. And these new features that were added some of them are leaning in that direction, and I think that's a direction that's good to continue to lean. And parallelism helps with that because of the possibility of running queries on really large volumes of data and getting an answer before you get tired of waiting for an answer. It's also important for OLTP. We're not really going to see this benefit in PostgreSQL 9.6, but one of the things that I'm hoping will happen in the future is that we will parallelize not only queries but also maintenance commands. And I suspect that many of you, if you have some experience in using PostgreSQL, have gotten tired of waiting for a vacuum or waiting for a create index or waiting for a cluster command to finish. Even though your overall workload is transactional, you're still going to have some bulk operations. And being able to eventually use parallelism to speed up those bulk operations is something that I think will be really, really good for a lot of people. I also think that the continued progress in foreign data wrappers is going to be pretty exciting. I realize this is a little bit more speculative position that not everybody in the audience may agree with, but I think the promise of foreign data wrappers is that they'll allow you to access local and remote data transparently. And we really don't have that today, right? In PostgreSQL 9.1 through 9.5, you can use foreign data wrappers, but they tend to get used for applications like ETL. You use the foreign data wrapper to get at the data that is in some other system, and then you pull it into a real table, and you do whatever it is that you want to do with it. And one of the reasons why you need to do that is because of the lack of optimizations like the sort pushdown and join pushdown stuff that I was talking about earlier. Your queries against that remote data source don't behave in the sort of obvious way that you might expect. Instead, they're really slow for no apparent reason. And so you're like, forget this, I'm sucking all the data into a local table. But I think that's a fixable problem, and I think there are interesting things that will happen as we fix that problem. I also think that the performance and scalability work that has happened over the past several years is going to continue. I think one of the most exciting directions for that work is looking at new storage formats. MySQL has had this for a long time. It has not been a great thing for them in all cases because it's resulted in a certain amount of fragmentation and everybody's got a slightly different storage format than everybody else. I think that's one of the reasons why the PostgreSQL community has been very reluctant to go in this direction. But I think it's becoming clear that there are some things that you can make vastly faster if you change the format that the data is stored in on disk. You can optimize for a read-only table or for columnar data or for a variety of other things. And so I think that work is going to be very important over the next few years. We also have some things that I think we need to keep working on that we haven't quite come to grips with how we're going to do them yet. Continuous availability is something that I see becoming a bigger and bigger problem for us, people want a database server that's actually up and fully accessible all the time. Not just some of the time, every minute, every second of every minute of every hour of every day. And you can do that with today's PostgreSQL pretty well if you're lucky and nothing goes wrong. But there are some challenges in actually getting to 100. 99 point something. I'm not sure how many nines you can manage today. Depends on how hard you're willing to work at it, to be sure. You can get it pretty good. And a lot of the technologies that we already have and some of the things that are in development are going to continue to make that easier. But I think that as a community, we need to think more about how we can get to 100 and make it easier to stay at 100. Another challenge that I think is before us is in the area of connection pooling. Connecting to the database server is a pretty heavyweight operation, and each connection uses a lot of resources. I think those are problems that are certainly not as bad as, say, not having schemas, but I think it is something that we want to try to address as we go forward. Hot is a huge advance. Nobody's going to deny that, but there are still some workloads where it's difficult to keep your table bloat under control, and I think that's an issue that we need to do more work on as well. But for all of that, I think that the future of PostgreSQL looks really good. We've gone from a low-performance database that was basically suitable for personal projects, something you did on your machine that's at home in the basement, to a highly scalable enterprise-class database. That's where we are today. That's a really exciting transformation. And we're continuing to innovate and add major new technologies to our stack of things that we do that are going to allow it to reach more users and more use cases. So please use PostgreSQL. If you can help with the development of PostgreSQL by reviewing patches, by testing patches, by writing patches yourself, whatever you can do to help out with the development of PostgreSQL is all really good stuff. We have made huge progress, but our continued progress depends on all of us working together to make the database better. And so I just ask everybody to pitch in. That's all I've got. I have a couple of minutes, so I think I can I take one or two questions? Yes. Yeah, so questions? Yeah.
Hi. What two parts to question? Just wanted to check whether the schema is under the MVCC in Postgres yet, and the other that trying to contribute to the mailing lists at times is a far more difficult in the interaction. Tom, I'm sure your recent interaction with Tom isn't very nice either. This thing is all completely wrong. Please, we need to rework on that and so on and so forth. So the interaction in the mailing list is a bit too blunt, and which in some sense is good. I can understand. But how does a new person who's joining the mailing list as far as development or trying to contribute persist with that from the group perspective, as in how do more people come in? Because the welcoming part to me is a bit more
So I didn't actually catch the first part of the question, but I definitely caught the second part of the question about the difficulty of interacting with the mailing lists. For a lot of people in this room, your first language is not English, and your culture is not American. And even if both things were true, it can still be a little intimidating to try to work on the PostgreSQL mailing lists at times, and certainly those things can make it harder because the sort of center of the community is around a bunch of people who are mostly American and European, and many of whom have English as their native language. Certainly Tom does. I think that part of the answer is that it would be nice if we could get other people to interact with us the way that we would like. I certainly have people say things to me from time to time, both on the PostgreSQL mailing list and, for example, in my kitchen, where I might have wished that person would have said that thing in a different way. But I guess what I would say is that, sometimes you have to be willing to adapt, especially when you're plugging into a big established community of other people. And I think that the PostgreSQL community generally rewards being fearless. You know you've won an argument with Tom when he stops replying. He doesn't necessarily say, oh yeah, you're right. In fact, that almost never happens. But sometimes he stops telling you you're wrong. And you got to just be willing to accept that that's the best that it's going to get. I mean, the reality is that, I can sort of say from my side as somebody who writes a lot of postings on the hackers mailing list, that, you do your best. You try to tell people things in the best way that you know how, and you try to be polite and respectful and all of that kind of thing. But also, like, you're really busy, right? And your boss is not grading you on how many emails you send to the mailing list. Your boss is grading you on results. So, if a little bit of edginess or a sharp edge to something creeps in there, that's usually because I and everybody who's a long-established member of the community are really trying hard to make PostgreSQL better, and sometimes, something slips out that shouldn't. So I just say, try to be patient with that. I think I only have time for one more question, so let me get a question from someone else. Yeah.
Hey, hi, my name is Anand. Actually, my question is on parallel queries.
Okay, talk loud.
Yeah, so is there any configuration that we need to do for that, for setting up parallel query? Or, I mean, in some cases it may not be good, because if you, as you say, there might be situation wherein one query may take all the resources
Right.
available.
So,
But then may not be good for other query which comes in.
right.
Right.
So-
is there something that we need to set up upfront wherein we say, okay, I need to have this query in parallel, is more this server or whatever this instance in parallel?
Yeah, so there are a number of configuration parameters that you can set around parallel query. You can limit the total number of parallel worker processes. You can limit the number of parallel worker processes that a particular query will use, and you can limit it to 0 if you don't want any parallel query at all. And there are also costing parameters you can tune. So yes, you can control that. I imagine there are other things that people might want to control too, but I kind of need some people to complain before I know what doesn't work about the system that I've got right now.
Okay, and one more question. So it's regarding the logical replication that you have explained, right? So in logical replication, is there any kind of monitoring wherein I can see the latency?
I don't know. Okay, I think I should stop because I want to give the next person a couple minutes to get up on the stage, but thank you very much.